Hello students, today we're going to be able to apply algebraic reasoning and definitions of angle relationships with vertical, complementary, and supplementary angles. So those are some new vocabulary words for you, which we're going to introduce today. For the warm-up, we did these a little bit more in the beginning of the year. Which one doesn't belong? So we have choices A, B, C, or D. What I want you to do is just pause the video and take a minute to choose any of the options and justify which one you think doesn't belong. So A would work, B would work, C would work, D would work. Doesn't matter as long as you have a good explanation. And try to use your best math vocabulary. Okay, so hopefully you should have done the warm-up by now, and here's some example answers. So you could have said A, because that appears to be a straight line, so a straight angle. So that's the only one that's a straight angle or a 180-degree angle. You could have chose D because it appears to be the only obtuse angle. Remember, an obtuse angle is between 90 degrees and 180 degrees. So, or you could have picked B or C for similar reasons. You don't need to have both of the things I've written down right. As long as you have something that justifies your work, then that's great. All right, so let's get into our key definitions for today. So we're going to be looking at different types of angles. Really like pairs of angles. So the first one is complementary angles. So it sounds like the word compliment, like I compliment someone, compliment their shoes, compliment their hair. But that compliment, just so you know, has an I here, where math complement has an E. Okay, so let's fill in some blanks to understand the definition of complementary angles. If two angles add up to 90 degrees, they make a right angle, which I think we generally know. And angles that add up to 90 degrees are called complementary angles. So any combination of angles that add up to 90 degrees is what we would call a complementary angle. And you see that picture here. Angle B plus angle A, when we add them together, they make that right angle there. So that's going to be a complementary angle. And so here's an equation we can use to kind of represent this. The measure of angle A plus the measure of angle B has to be equal to 90 degrees here. Angle A, angle B, we add it together, we need to get our 90-degree right angle. That M, that means measure of, and this caret-looking thing means angle, which we talked about on Friday if you were here. So the measure of angle A plus the measure of angle B has to be 90 degrees. So that would mean like what degree the angle is. So since angle A and angle B add up to 90 degrees, they are complementary. Okay, so that's one definition. Complementary angles and supplementary angles go together. So if two angles add up to 180 degrees, they make a straight angle. And angles that add up to 180 degrees are called supplementary angles. So that's what we have here. We have this angle, AOB, and then this angle, BOC. And then together they add up to 180 degrees, a straight line, so we'd call them supplementary angles. So I'll write that down there. Since angle AOC and angle BOC add up to 180, they are supplementary angles. And in equation form, we'll say the measure of angle AOC plus the measure of angle BOC equals 180 degrees, because this straight line, straight angle is 180 degrees. If these two make it up, they would have to add to that. And then lastly, we're going to look at vertical angles, which are a little bit different. So for vertical angles, we're told that when two lines intersect, two pairs of vertical angles are formed. Vertical angles are across from each other and are congruent, meaning they have equal measure. So let's pick our pair of vertical angles in our picture. A and B are vertical angles. They're across from each other, formed by the intersection of the two lines. And if they're congruent, that means whatever angle A's measure is, say it's 30 degrees. Then angle B is also going to have 30 degrees. It's also going to be 30 degrees. And then we have a second pair. Angle C and angle D. Those are also vertical angles. They're across from each other, formed by the intersection of two lines. And again, they're going to be the same. So it doesn't make perfect sense for the diagram, but let's say it's not drawn to scale. This is D is 150 degrees. Then C would also need to be 150 degrees, for example. So when we write equations and solve for missing angles and values, by setting the measures of vertical angles equal to each other. So we get that the measure of angle A is going to be equal to the measure of angle B, and the measure of angle C is equal to the measure of angle D. Again, for example, 30 degrees would have to be 30 degrees. 150 degrees would have to be 150 degrees. But sometimes we'll have equations with variables in them, which is what we're about to see. So those are our 3 key definitions for this lesson. So then let's move on to some practice, which is combining these terms with so this is the geometry with the equations we've been doing in the past few weeks. So, fun stuff. So we're going to be writing and solving complementary angle equations. So we are told here that ray EG splits a right angle, DEF, into 2 angles, DEG and GEF. And we want to find the value of x, is what they're telling us. Complicated, but not that hard if we use what we know now about complementary angles. So, going back to what we had, complementary angles add up to 90 degrees. So I can take the measure of DEG right there. I can take the measure of DEG right there, add it with the measure of GEF, and that needs to equal 90 degrees. Because it's a right angle. Okay? And then we'll be able to solve the equation that we get. So what is the measure of DEG? That is 3x degrees, they tell us. I'm not going to write the degree symbol right now, but it's going to eventually be degrees. That's like the unit. And then the measure of GEF, they tell us, is 36 degrees. So when I add those together, I need to get 90 degrees. So that's going to allow me to solve this equation now for x. And how do we solve an equation? Well, hopefully you know by now. If you don't, it's not going away. So this is the time to learn. All right, I'm going to rewrite my equation. 3x, I'm adding 36. I want to undo that. So I'm going to subtract 36 from both sides. 36 minus 36 is 0. So I'm going to cross that out, or write plus 0. Either's fine, and I just get my 3x on the left. And on my right-hand side, I have 90 minus 36, which is 54. And then lastly, I have x times 3. I have to undo multiplying by 3. So I'm going to divide by 3. And when I do that, I'm going to get 18. So the value of x is 18, which is great. And going back to this equation, or to my picture, that means this is 36 degrees. This has to be 3 times 18, since x was 18, which is 54. So this is going to be 54 degrees. That's going to be 36 degrees. But in this case, they're just asking you to find x. So x equals 18. Okay? Fun, I think. This is a geometry I really like. All right, and then we're going to look at example 2. Doing that with solving vertical angles. So we have the angle of MNQ and the angle MNPNR are vertical angles. What is the value of x? Okay, so looking at my picture, this angle plus this angle says vertical angles are blank. Well, what could they be talking about? Vertical angles are across from each other, maybe that's what they're saying, and are congruent, meaning they have equal measure. I think that's what the book wants. They're congruent, so they have equal measure. So the equation, something, can be written to find x. Well, what I wrote down is we can write equations and solve for missing angles by setting the measures of the vertical angles equal to each other. Okay? Well, this angle and this angle are vertical. So I can set them, this angle and this angle are vertical. So I can set those two equal to each other to find x. So 3x minus 6 is equal to 114. Can be used to find x. And then lastly, we just need to solve that. Okay, so I have 3 times x minus 6. You ask yourself, okay, I want to get rid of that minus 6. How do I do that? I'm going to undo subtracting 6 by adding 6. So I add 6 to both sides of my inequality. 114 plus 6 is 120. On the left-hand side, I have minus 6 plus 6. That's going to cancel away to 0. Those undo each other. They go away, and we just bring down a 3x. And now again, I have x times 3. How do you undo multiplying by 3? You divide by 3. So I divide both sides by 3. The 3's cancel as they always do, and I get whatever 120 divided by 3 is. As a note, this is a great thing. I can do this in my head, and I think many of us, at least if you know your multiplication facts, you should be able to do this in your head. 12 divided by 3 is 4. So since I know that 120 divided by 3 is just 40. Okay? So the value of x is 40. All right, that's all I did with the notes for my other classes. For Are You Ready for More? You're welcome to give these a try, depending on timing. This is just like the ones we just did, but with supplementary angles. So I think pretty straightforward. And that one, it's just going to equal 180 instead of 90. This one is a little bit more of a challenge. So feel free to try it. Ask me about timing. Make your decision.